Hello everybody and welcome at Jakarta 1. My name is Marcus Karg. I'm a JAX-RS committer and Jersey contributor. Back at JCP times I served in the expert groups JSR 339 and 370. In particular, I'm not employed with any JAX-RS vendor, but I'm more like a user's ambassador. So I do have a different angel than most of my co-workers, as I'm not bound to business plans or work schedules. I do not care for marketing or strategic targets or committees. My main focus is simply on real-world usefulness for the average programmer, and that simply is why I wrote most of the new features of JAX-RS 2.2, which we will release as soon as we can. I assume this is why you asked me to do this presentation today. So let's see what's in the box for you. So let's talk about Jakarta, RESTful Web Services, status quo and the future. Before we begin, there is a GitHub page where you can see the overall progress of the project. I'd like to invite you to visit that page regularly. You can see the top committers. Currently it's me and Christian. And you can contribute by filing issues, pulling code, or opening merge requests. Since JAX-RS 2.1 was authored, which is years ago, the IT world has changed a lot. The classic deployment option for JAX-RS applications is application servers. If workload increases, you need to spread your workload on more and more machines. You need to scale up. With classic application servers, this implies adding complete application server instances with all their features, needed or not, as the application servers cannot know upfront what features your Java EE application will use at runtime. So it provides more or less all of them, which leads to reserving more resources than actually needed, possibly much more. And it implies adding complete operating system instances, needed or not. Hence, horizontal scaling of classic application server products is inefficient and expensive. The typical solution to this problem is scaling only the needed pieces within a container. This is what a Kubernetes-Docker combination does. No more useless resources claimed. No more duplicate operating systems. This is efficient and cheap. But how to run a JAX-RS application without an application server? There is no standard for that scenario in JAX-RS 2.1. Certainly, there are products that can do that. For example, you can use Helidon or Quarkus. But again, these are not standards, these are products. Also, you could use, for example, Jersey's native modules and APIs. But again, that's a product, not a standard. This was just one example why JAX-RS has to evolve. Another environment we need to talk about are RESTful devices. You maybe heard of the term Industry 4.0, which is rather common these days, at least in Germany, where we try to provide more intelligence into manufacturing fields. And intelligent devices play a big role here. And these devices have to communicate. And some of the devices shall communicate in a RESTful way. So we have to provide a way to run JAX-RS on these devices too, which is a bit hard to do. If you look at this device here, for example, it's a small computer you can obtain in the internet for a few bucks. And it just has 256 megabyte RAM and a single 1 gigahertz core. And if you try to start Glassfish on this, you will fail. This will just not work. So an application server is a no-go here. We have to provide something different. And this is also doable with JAX-RS 2.2. If you look at the Java SE Bootstrap we will provide. We talk about that later. So the effects on JAX-RS are that JAX-RS has to start and stop instantly in these environments. It should consume less resources. It must provide its own HTTP server. It must be able to read an external configuration, and it must accept application provided resources, because these were the things that an application server provided so far to JAX-RS. And if you take away the application server, these are the points you have to be able to do. You can imagine that we have to change some parts of JAX-RS, and this includes that we have to drop some things you know from the past. Let's say we kill the WORA principle at least a bit. Not every feature will survive. We have to change to make progress and to be future compatible. And some of these are listed here on the slide. In Java SE 11, there is no more JAX-B bundled. I think you heard of that before. And JAX-B was one of the features that were enabled in JAX-RS right from the start. You could use JAX-B to bind your objects to XML, and everything was provided by Java SE, in fact. So now that's not there anymore, we have a problem. We decided not to bundle JAX-B anymore. Also in JAX-RS. That means if you want to run an application that needs JAX-B under the hood, then you have to provide it yourself. Which means if it's an application server, the application server will provide JAX-B, I hope so. And if it's not an application server, like a cloud environment, then you have to provide it yourself, which means possibly bundling something you pull from Maven Central by adding a dependency. So it's not hard to do, but you have to provide it. It will not be there by some kind of magic anymore. Another point that it's broken by intention somehow is that the package is not javax.ws.rs anymore. It's now jakarta.ws.rs, which simply was decided by the Eclipse Foundation because of trademark issues. So if you want to make your code run, then you need to rewrite it. That includes rewriting the Java code, not only the dependency in the POM file. This will start with JAX-RS 2.2, which is here rather soon. And then in JAX-RS 3.0, it's even worse because we are starting to get rid of the add context annotation. That's because we want to get rid of the dependency injection framework that JAX-RS had right from the beginning. The reason is that there is another dependency injection framework, which you know is CDI, and we want people to use CDI. Why are there two dependency injection frameworks? Simply because two projects started at the same time with the same intention. The first one was JAX-RS, and JAX-RS needed dependency injection, so it came with its own framework. There was no standard framework. And the second one, which started later, was CDI. And CDI made a race, so we decided drop our own framework and use CDI. That's not so easy as you think, because the add context annotation can be used to do things that add inject cannot. So either the CDI specification will learn to support these use cases, or we have to find a different solution. The future is open here and the discussion is going on. So this is very, very interesting to see how this develops. But in the end, definitely add context will die and you have to rewrite your code, and then you can use CDI really everywhere. So let's take a look at the roadmap in version sequence. What we have currently is JAX-RS 2.1 release 6, which is mostly the same you had in Java EE8, but now branded as Jakarta EE. So this is what we have today. What we get next is JAX-RS 2.2, and the top feature is what I already explained in the introduction about the drivers of the next changes. It's the Java SE Bootstrap API. The slide says it's delayed because it was planned many months earlier. I'm sorry for that. Technically, it's done already, and it was done months ago. We just cannot release it because the roadmap of Jakarta is different. They want Jakarta EE8 to be released completely first. So this is in the queue, it's technically done. You can download it, you can use it, but it's not an official standard right now. So I already said the top features of this release is that it's instant on-off, it has low resource, it includes an HTTP server, it reads external configs, and optionally it can support microprofile config API. And this is a very interesting point because there's discussion going on about microprofile config versus JAX-RS standards. And what we try to reach is that we get compatible in some levels. So here we said if a product can use microprofile config API, then this configuration will be used to start up the Java SE Bootstrap API of JAX-RS. This is very interesting. After JAX-RS 2.2 is released, we try to do the releases more often. I cannot tell you the exact cadence that we will be able to deliver, but our plans are that we can release every quarter or at least twice a year. So the next one in sequence will be JAX-RS 2.3, which will provide support for CDI 2.0, including CDI SE. So this means that the support for CDI, which currently is optional in JAX-RS 2.1 and 2.2, will become mandatory for the runtime, not for the application. The application can decide whether it uses CDI or whether it still keeps the add context dependency injection framework of JAX-RS. But the runtime must support CDI. So we will start here to deprecate add context. It will still run, but it's clearly marked that we will remove add context in a later release. And there will be support for context resolvers for JSON-B. This is a feature you need when you want to use JSON binding API together with JAX-RS in a more sophisticated way. You currently can use JSON-B. It is working already, but you cannot configure it. There is no standard for configuring the JSON-B runtime. And starting with JAX-RS 2.3, the default way will be that you implement a context resolver that provides a configured JSON-B environment. So the focus for JAX-RS 2.3 clearly is that we can process application provided resources. Again, I started with that we want to replace some of the features application servers provided underneath JAX-RS, and application provided resources is one thing we have to do in future. So we can do it by these two things, by supporting CDI to inject application provided resources and by configuring JSON-B environment. By the way, I want to say that this roadmap is not carved into stone. We are an open project, and besides what I told about JAX-RS 2.2, everything could change in theory. Actually, I don't think that much will change because what I tell here today is discussed already among all contributors, among all vendors, and we have a roadmap which lists these features already, and I'm pretty sure they are already implemented in most of the products. So while in theory the future is open, I'm pretty sure this is what JAX-RS 2.2 will bring. Next on the list is JAX-RS 2.4, and this is rather far away. So I'm not so convinced that what we plan today, which is JPMS support and support for Java SE larger than 8, is actually what comes in 2.4. but it's at least our plan. And if you have any features that you think are good for addition to 2.4, then don't hesitate to send them to the mailing list, and we're happy to discuss them. So far, all version numbers you saw are 2.x, and that had a reason. The reason is backwards compatibility. You can be assured that your applications will still run on JAX-RS, or I need to say Jakarta REST version 2.x. Next on the roadmap is JAX-RS 3.0, and possibly your application won't run anymore. That's because I already said that we replace add context annotation by add inject annotation. So we might need you to change your programs. Again, this only will happen if you run on JAX-RS 3.0. I don't know what the application server vendors or the JAX-RS implementers will do, whether they provide different products for JAX-RS 2.x to JAX-RS 3.0, or whether they manage to run both in different containers. I don't know. But the plan for the standard API is clearly to get rid of the dependency injection framework by JAX-RS 3.0. So you should start to think overhauling your existing applications, because there will be a day when add context is definitively gone, and it's with JAX-RS 3.0. On the other hand, this will not be tomorrow, and it will not be in 2 months. It will not be even by end of the year. It will be possibly in middle or end of next year. So you have time to do the needed changes. You don't need to be hasty, but please keep in mind the changes have to be done. For the JAX-RS team, it's like the switch from Java 8 to Java 9. The introduction of the modules framework was really a nightmare for many programs, including some of my own open source projects. And the introduction of JAX-RS 3.0 might become like an earthquake for some applications. On the other hand, CDI is here for a long time, and maybe it's just time to overhaul your applications anyway. So don't fear that release, but expect some troubles. This slide looks in the very, very far future. It's JAX-RS 3.1, and we have no clue what comes there. If it's the Flow API from Java 9, it might be in that release, it might be earlier, I don't know. It might be NIO. That far future is really open for discussion. We have no clue what's really the most important thing there. And we invite you to discuss with us. Come to our mailing list, discuss with us. Anyway, we will start with implementation of JAX-RS 3.0 in 1 or in 2 years. So there's plenty of time to discuss 3.1. Let's look into release 2.2 once more in depth. So this is what you can do today. JAX-RS 2.2 provides a new API. We call it the Java SE Bootstrap API. Actually, the products implementing JAX-RS were able to run on Java SE for a long time. JAX-RS mentioned Java SE environments right from the start, but what was missing there was the code that I have to write when I want to bootstrap it. And what we did was we looked at the ways the implementations were working, we adapted the APIs they had, we discussed, and we came up with an API that now all implementing products that are able to run on Java SE must support. So this means we do not force the vendors to be able to run on Java SE. But if they are able to run on Java SE, then we force them to implement this API. So why did we do that? Because we want that you can write a simple hello world application and have a main method, and in that main method write code that starts up a JAX-RS container. And this is pretty much what this API does, and this is what I will demonstrate later in this presentation. The main features that this API provides for you is that depending on the actual implementation, you have more or less instant on-off, which means your application will boot and shut down in 1 second or possibly less than a second, which is really great compared to application servers. Application servers need typically very, very long to boot because they don't know what features you need. Here we have a different situation. In a Java SE environment, your program must provide everything you need. So if there is nothing your application expects to get, then the Bootstrap is rather easy compared to what an application server has to do. Another thing is that we have very low resource consumption. This also is because the application server simply doesn't know what you want to do, so it provides a lot of resources which need system resources on their own. Your own Java SE program knows exactly what it wants to do, so it's very, very low resource consuming. Also, we have an included HTTP server. We don't mandate a particular product, but we say if an JAX-RS implementation is able to run JAX-RS applications in Java SE environments, then it must be able to start up some HTTP server. For example, Jersey is a modular implementation and it provides several HTTP servers you can choose of simply by binding different dependencies, which is a very cool way to simply switch the implementation. I don't know about the other JAX-RS implementations, but I assume they will be flexible in a similar way. Also, we can read external configuration, which means, for example, the host name, the IP port, or possibly the class name implementing the HTTP server. This is a feature that Jersey does. You can have some file, for example, or some environment properties that tell the Jersey implementation which HTTP server you like to have. So you bind, let's say, Netty and Chatty and Grizzly, and at runtime, the user can decide which HTTP server it wants to run. I don't think that many people will actually do that, but it shows how flexible your program becomes when using the Java SE Bootstrap API external configuration. Certainly, this configuration can come from different sources. So, for example, we can have a file, we can have environment variables, and certainly we can have things like the microprofile config API. I told earlier that this is possible, and the interesting part is that even without the microprofile config API, this flexibility allows you to run your application in a very lightweight Kubernetes environment, because Kubernetes is able to provide, for example, environment variables. So here we have clearly a cloud native feature because we can run JAX-RS in Kubernetes without any particular product in between. If you want to try out these features before JAX-RS 2.2 is released, you need to take care of the version numbers. I have set up this bleeding edge cookbook for you, which you can follow to compile exactly what you need. And I literally mean compile, because you need a runtime, and there currently is no runtime released that supports JAX-RS 2.2. So For example, you can take Jersey, there's a branch JAX-RS 2.2. If you compile that branch, then you will be able to do the same things I will show you later in this demonstration. For JAX-RS itself, it's not released. You also have to build it on your own with mvm install before you will be able to compile Jersey. So it's not that easy, but I'm very confident that you manage to do that before there is a binary release. I mentioned the shade plugin here. You can just ignore that. It's just because I am using a shade feature here, which I will show you later, which has nothing to do with JAX-RS. And this feature is only in the master branch, which is not released now. Okay, now let's dive into the actual code. I will demonstrate you the JavaSC Bootstrap API, so you have at least seen it without compiling it on your own. And after that, I will talk about some of the numbers I have taken with limited devices running this application, so you will get an understanding what the actual measurable benefits are of running JAX-RS applications on native Java SE instead of using an application server. Let's have a look at some real code. I have a small JAX-RS application here, which simply prints a string on screen. It's not worth to tell what the application actually does. Just let's look at the code itself. I think most of it is self-explanatory, so I will only show you the hotspots, what the interesting points are, what we have changed in the JAX-RS API, so you have an idea what you can do with JAX-RS 2.2 and later. I talked about the problems we have bootstrapping a JAX-RS application outside of an application server, because we have to provide services ourselves that normally application servers would do. So what we have here is the bootstrap code for a JAX-RS application. We have a normal podshow class, which has a typical main method as you are used by Java SE. And if we want to configure this application, for example, we want to tell the bootstrap code the IP port that we want to use, then we simply use normal Java features for that. There is no special feature built in. We just can do whatever we want. For example, I could imagine this is running on Kubernetes, and Kubernetes provides some environment variable. Then we could parse it, or here in this example, we also have a default, and the default is the number 0, and 0, for example, would tell the system I want automatic check for a free IP port. So this is plain Java. There is no JAX-RS so far. But what are we doing with that? And now this is the interesting point. Normally, the JAX-RS application server would create an instance of the application and ask the stat for the resources it needs. And we have to do that on our own. So first thing I do, I create an instance on my own. This is normal Java, plain Java as you know it. And then I have to put this instance into the JAX-RS runtime. So we added an API. Currently it's named JAX-RS.start. This might change in the next weeks. We're discussing the names, but the idea is the same. And we have to give it a configuration. Again, normally an application server has that configuration, but we have to provide it. So we have added this configuration class and a builder API. And using that builder API, I can set different settings like the protocol to use, the host, the IP port, but also much more. And it's not limited to that. You can also use specific properties of your particular JAX-RS implementation. For example, I could give jersey specific configuration options here. There are more options inside of the configuration builder. We can also, for example, give it an external configuration. So we can have a supplier for properties. We could also have external configuration systems. Such a system, for example, could be the microprofile config API. So this is open to accept configuration parameters from more sources besides the manual builder API shown here. Now with this configuration and this application, JAX-RS is able to start an HTTP server. Now the question is, where is the HTTP server coming from? This is dependent of your actual JAX-RS runtime you are using. I will show you the POM file later, so you have an imagination what the possibilities are here. Just let me go on with this code first. JAX-RS is starting the HTTP server, and it is providing another stage, and that stage is called when the application server actually was able to start up the JAX-RS application. It provides an instance. An instance is a pointer to the class of your JAX-RS application running on the HTTP server. So you have some kind of live access to this instance. And this is nice because we can do some things with that. For example, we can tell this instance to stop from an external trigger. The external trigger we are using in this example simply is a shutdown hook when I try to kill this Java VM. For example, Kubernetes wants to shut down this container, then the shutdown hook will run, and this code would execute instance.stop. Instance.stop, by the way, also has another stage where I can react on the end of the stopping. I'm getting a stop result. This is nice in case you want to log, for example, whether the shutdown was successful or whether there had been problems. You can even access native shutdown result codes of your application server products underneath. Sorry, not application server, I meant HTTP server. In my example here, I simply log the native result by unwrapping the JAX-RS standard class into some core class here. I could provide, if I know the class that the HTTP server provides, I could unwrap it into this class and access its members. As I have a 100% pure JAX-RS application here, I can just say it's an object. Another nice thing I get from the instance, I can ask for the actual configuration. So what's the difference between this variable and this result? This variable here is the configuration I want to reach. So for example, in Kubernetes, I said I want to run this JAX-RS application on HTTP localhost and on port 8080. Then there is no difference to the actual configuration. Either it can start it or not. But there are also dynamic properties. For example, if I provide a 0, and this is part of our JAX-RS 2.2 standard, a 0 to port, this means the JAX-RS implementation product, like Jersey for example, shall look up a dynamic port. So inside this configuration, port is set to 0. Here, if I ask the started application for its configuration, I can ask the port actually used. So this is what this code does. It builds up a URI and prints it on screen. So if we start it, we actually see the chosen port. Okay, here it is. So this is just one small example of the API, what you can reach. Certainly, thanks to the lots of properties that are built into the different JAX-RS implementations, you have much more things you can do. Another nice thing you can do, and I want to demonstrate this shortly, is debugging. I always had a problem when I want to debug JAX-RS code on a real application server. I have to start up the application server, which is rather slow compared to Pocho. And when this is running, it's running in a different Java VM. So I have to set up remote debugging. And this is slow and it's error prone and it's just not nice. Even with all the plugins you have to install the plugin. It has to work. It has to fit the IDE's version and so on and so on. I don't like that. I just want to start it as a normal program and debug it. And you can do that with this new JAX-RS Java SE Bootstrap. It's just like normal debugging. It is normal debugging. Go into Hello World. Now it's starting up the debugger view. And it stopped on this breakpoint. And from this point on, I can use all the features built in the VM. Again, this is not a special Eclipse plugin you're seeing here. This is the normal Java debugger. There is no specific built into Eclipse for that. And here I can do whatever I want. So just go on. And due to the fact that JAX-RS uses inversion of control, debugging is a bit more complex because I have to start a request. Now again, I don't have any special tooling here. I just use curl to start a request. Oh, sorry, that was the wrong port. That's a bad thing when using dynamic ports. You have to match the port. Okay, now you have seen in the background the debugger stopped on another breakpoint. And what we see here is that it stopped inside our JAX-RS resource, and I cannot actually guess what it's going on in the next step. JAX-RS has lots of steps before and after that, like filters, interceptors. But with the debugger, due to the fact that it's a normal Java code, I can see what happens. I just have to go on. I can step into. Let's do that a few times. Or I can go on, jump to the next breakpoint. The next breakpoint is in a filter, so we can see the filter. We can see the requests. We can see the response. Let's open this so we can see it a bit more. Here's the status that we got. It's okay. We can go on. We step into an interceptor. We are about to proceed with the next interceptor, so let's just change the code. Eclipse is able to replace code live, so let's do that. Again, we are in the debugger. And it jumped to the breakpoint again, and we can debug the change code. Certainly, this is no magic. This is what Eclipse does with any code. On the other hand, that's so great about it, because now a JAX-RS application, even with the inversion of control, is debuggable in Eclipse without any magic, without any special tooling, without any hassle. And if I want, just let's start another request. If I want, I stop this thing within seconds, start it again, and do the same again. Because I don't have an application server. It's fast. I can do that as often as I want. So the turnaround time, the iteration time when developing JAX-RS is really, really great and fast without any special tooling. And that's what we want to reach with JAX-RS in the future, that developing JAX-RS and executing JAX-RS and deploying JAX-RS feels like a normal Java code and feels like a normal cloud native application. I wanted to tell you how this all works. Where is the HTTP server coming from? You haven't seen just JAX-RS standard code. There was no product specific APIs called. Let's go to the POM file. I think you're familiar with the syntax and can read it. There is not much very complex inside it. This one tells I want to use Jersey. I could use any JAX-RS implementation. I just like Jersey. I'm a contributor to Jersey, so I have chosen that one here. I tried it with others. It's working, actually. So certainly we need JAX-RS. Then we are adding JAX-B, because I said there is no JAX-B anymore after Java SE 11. So we have to provide it on our own. There is no application server providing it for us. We also have to provide an implementation of JAX-B. Certainly the AP itself is not producing anything without an implementation. Then this one is the very core server product of Jersey. This is the dependency injection framework providing the content for add inject annotation. This is the actual HTTP server. And there is one nice thing. In Jersey, everything is a module. You can change modules among lots. And I change now just by changing the POM from netty to chatty. And Eclipse immediately is recompiling the application. And now I start the same application without changing any line of the code, without any line of the configuration. And it has booted. And it is working. So this is the proof that our IDE is working. We can start up a JAX-RS application within a second or within seconds, and we can change the underlying technology just by changing the class path, not by changing the configuration or by changing the application itself. Sorry, this was the wrong port. Certainly this proves nothing. Let's use the right port. Okay, so here's the result, 200. Okay. And since everything in Jersey is a module, we also have to provide the possible content types as modules. So here we start up the JSON binding, and here we start up the Java XML binding. So if we don't need XML, we can just drop it. So I will keep it. And now let's look at the class path. This is the complete class path of the application, including all technology needed, including all APIs, including Jersey container, including Jetty HTTP, including the JAX-B implementation I have chosen, and so on and so on. And this is all you need to run inside your Docker container later. There is no application server. There is not anything more that you really will need. You will not load any classes that you will never fire up. And this is really great, I think. And this was the one feature that we thought is the signature feature for JAX-RS 2.2. There are more smaller features in the box. Read the release notes when we have released them. and try it out as soon as you can. Here are the numbers I talked about earlier, and I hope they look good to you. What we see here is that I have measured the boot time, the jar size, the amount of limited memory you need to run this, the amount of limited stack you can run on, and the number of Docker space I provided for my application. And in the bold column, you see my actual Hello World application, which was Java SE, Jersey 230 preview, Netty, and JAX-RS 2.2. And the boot time was about 2.5 seconds. I said earlier it's able to start up in less than a second. This is actually true, but it depends on the device. So the device here, it was very, very, very limited. It was some kind of system on a chip device, and it only had 256 megabyte of RAM. It has a single core, and it's running on a gigahertz. So when you start the same application on your laptop, it will boot in much less than a second. So on this limited device, you can run it with a 6 megabyte jar. So a 6 megabyte jar was 6 megabyte. Let's look on the right side. We have Java EE server with JAX-RS 2.1, which comes with 142 megabytes plus your application. So this is the difference you get from running it on Java SE. And look in the first row. The startup time of the application server on that device would be around 60 seconds. I couldn't actually measure it because it failed due to the missing memory. I tried it later in a comparable Docker container, and it actually needed around 1 minute just to boot with this limited adjustments. So you can start very much faster. You need very, very few memory compared to the application server. And this is actually measured numbers. So this is the proof that using Java SE as your foundation instead of an application server is not only possible, but is very beneficial. And no, this was neither Quarkus nor Halidon. This was really only the code you saw in the live demonstration. The application server used here, by the way, was Payara. Once more, I'd like to invite you to discuss with us. Unfortunately, I couldn't attend live to Jakarta 1 today, so if you have any questions for me in person about this presentation, about the numbers I measured, you can write directly to me. The address is given here on this slide. And that's pretty much it. Thank you for your interest in JAX-RS. If you'd like to contribute, just open an issue in the GitHub tracker or write to our mailing list. Your help is very appreciated. Have a good time. Bye!